Smart Talk Series. Lecture 1, Spatial Technology for Better Traffic Management by Dr. Santosh LG. Turtle Smart Solutions LLP is a civil engineering consulting firm in Kerala which has acclaimed outstanding reputation over a small period of time. The firm concentrates in design and PMC services of amenities like roads and highways, bridges, modern slaughterhouses, sewage treatment plants, community development and town planning projects, and allied sectors. The firm works with contractors by providing project management consultancy services and our laboratory services in their works and helps them improve their construction quality. The firm believes that academic industrial collaborations can impart significant contribution to engineering community. Smart Talk series is such an initiative to provide a knowledge sharing platform among engineers through interactions with eminent technocrats from academics and also industry. Today, we begin with our first lecture, and we are fortunate to have a prominent figure in one of the most relevant and futuristic company. Now, I request Engineer R.S. Ganga, Executive Engineer, Thiruvananthapuram Corporation and District President of Association of Engineers Kerala, AOEK, to deliver a few words about AOEK.
Thank you. Good evening, everyone. On behalf of the organization Association of Engineers Kerala, I thank you all for joining us today. Association of Engineers Kerala is a non-profit organization of about 4,000 plus engineers from public works, irrigation, and local self-government departments of Government of Kerala. Every year, we conduct technical sessions to update our engineers about new technologies. We also conduct an annual sports and cultural meet for the serving and retired engineers and also for their family members. The association encourages research and free discussion on engineering problems we are facing. We publish periodicals containing articles by engineers regarding technical and non-technical subjects. This is our first technical session of this year. On behalf of Trivandrum District Committee, I congratulate the organizers, Turtle Smart Solutions, for conducting this event. I am very glad to be a part of this. I also express our gratitude on behalf of AOEK to Dr. Sri Santosh LG, Assistant Professor, MSRIT, Bangalore, for taking his precious time to share his valuable knowledge and experience with our engineers. I hope the session regarding spatial technology for better traffic management will be useful for you to provide better service to the community. Thank you.
Thank you, ma'am. Now, I request Engineer Vinod Shamsuddin, State General Secretary of Association of Engineers, Kerala, to officially inaugurate the lecture series.
Madam, you can just tell once more. I think sir has just left and he's rejoined.
Now, I request Engineer Vinod Shamsuddin, State General Secretary of Association of Engineers, Kerala, to officially inaugurate the lecture series.
Good evening, Dr. Santosh. Good evening, all. Can you hear me?
Yes, we can hear you. You can continue. Yes.
Good evening, Dr. Santosh. Good evening, all. This is a wonderful effort by the Turtle Smart Solution in association with the Association of Kerala in organizing such a lecture series. Turtle Smart Solution has always shown excellent commitment to the engineering industry. They have shown great professionalism in their design and project management systems. In fact, this talk series will help the engineers fine-tune their technical knowledge, and this will empower them with the new technological advancements of the industry. The talk series like this will in fact enrich the collaboration between the academic engineers, those engineers who are working in the academic sector and those who are working in the industrial sector. For those engineers who are working in the industrial sector, will be able to deliver their services to the society and the common man more effectively. And for those who are working in the academic sector, will be able to understand the real-time industrial problems more effectively. I hope that more and more talk series like this will be organized in the nearby future. On behalf of the Association of Engineers Kerala, I take this opportunity to thank Turtle Smart Solutions for joining hands with us. As I hereby declare this event inaugurated. Thank you.
Thank you, Vinod sir. Now I am to invite Dr. Vivek R. Das, Associate Professor, Ramaya Institute of Technology, Bangalore, and our firm's technical advisor to formally introduce and invite our guest speaker.
So first of all, a very good evening to all. It is a happy occasion for me to introduce one of my best colleague, Dr. Santosh LG. So Dr. Santosh LG completed his BE in Civil Engineering from ETU Belgavi and his MTech in Remote Sensing and GIS from NITK Surathkal and obtained his doctoral degree from Indian Institute of Science, Bangalore, mainly in the area of municipal solid waste management. He has 6+ years of academic and 12 years of research experience. Presently, he is working as assistant professor in Department of Civil Engineering at MS Ramaya Institute of Technology. He also worked as project intern at Regional Remote Sensing Center, ISRO, Bangalore. He has been academia and guiding 3 PhD research scholars along with postgraduate and graduate students. Over the course of his career, he has organized many workshops, FDPs, and seminars, and also delivered many technical talks at reputed organizations such as NIT and IACs. His research falls in the area of remote sensing and GIS application in water resource management, transport planning, municipal solid waste management and landfill, water resource engineering, probability and reliability based approach. He has published more than 30 research papers. Recently, he has published a paper in a Q1 journal. It is widely accepted internationally. Apart from academia and research, he is also a private consultant providing solutions for real-world problems such as urban hydrology, urban flood hazard assessment, mitigation, etc. He is a member of various professional bodies such as Indian Society of Remote Sensing, Indian Geotechnical Society, associate member of ASC. He has also been actively involving himself in society, environment, and water conservation activities through various NGOs in Bangalore and outside Karnataka. With this a small introduction, I invite my colleague and my beloved friend, Dr. Santosh LG, to deliver the talk. Thank you.
Thank you very much, sir. So shall I start?
You can start.
Yeah, so very good evening to everyone, for all the participants. So I'm sure many of you may be there in the hangover mood of the past weekend, or many of you must be tired with the long working day. That is the first day of the working week. So anyway, so have a Josh for 1 week, I mean 1 hour. Okay. So the topic assigned to me for this technical talk series is spatial technology for better traffic management. So we all know that how it is difficult to transit across cities like Bangalore, Chennai, Delhi, or Bombay, especially metropolitan cities in the early morning or in the evening where there is a peak traffic flow. Is it not? So it is a very difficult event, or it is very difficult to go back to the home after a long working day, tired working day, and it is very difficult, especially in cities. So it is very much essential to have a smart transportation facility. So how to create this smart transportation facilities? So we can adopt this spatial technologies, that is advanced spatial technologies. So which will be able to provide solutions for having a smart transportation facility. So in my technical talk, I'll be briefly introducing about the traffic management. What are the components of traffic management? What are the causes for traffic congestion? And then I'll be briefly giving an introduction to what are the advanced technologies for better traffic management. Then I'll be briefly introducing about the spatial technology and components of spatial technology. And I'll be giving a brief explanation about each component of this spatial technology. Then I'll be covering some of the important applications. So where in which, we are having or finding some solutions for having better traffic management. And I'll be concluding my presentation. So let us understand this traffic management. So what is a traffic management? So when we say that traffic has been properly managed, which indicates or which infers that we will be having a safe, orderly and efficient movement of vehicles. Okay. So as I mentioned in cities, especially in urban cities or in metropolitan cities, so it is always a problem of traffic congestion. So since we are having this heterogeneous traffic condition, like we have two-wheelers, then light motor vehicles, and then cars, buses, heavy motor vehicles like trucks are causing a lot of problems which is leading to traffic congestion. So some of the common causes which are causing this traffic congestion include construction activities that are going along the side of the roadways, or it may be accidents. Even if we have experienced in every day of our traveling time, we experience some of the other things like small damage to a vehicle, small touch up where drivers are getting into fight. So that all creates lot of traffic congestion. Then traffic overload, that means lot of vehicles are moving in same direction, so that will also lead to traffic congestion. So, and other thing is that when it comes to Indian contest, so the road surface condition, so when we don't design or construct according to the IRC codes, so having a proper quality assurance, so then there will be a lot of traffic congestion, which also leads to the accidents. So, and then signal time intervals. So there may be malfunctioning happening in the signals that are installed in junctions. So sometimes that also causes a lot of traffic congestion. So these are the common problems that we undergo every day when we are in traffic, or when we are moving from one point to the another point. So in order to have effective traffic management, so here you can see I have mentioned some points. So starting from the factual information. So that means we cannot assume anything when we are hoping for effective traffic management. We need to understand what is happening in the traffic. Okay. So understanding of the facts that are in the traffic, that is very much essential to have an effective traffic management. So then road inventory. Road inventory includes.
This one is wrong. Let's solve it again. Hey, Yashwant.
Excuse me, can you mute your mic? So road inventory includes, so having or maintaining an inventory about the geometrical dimensions of the road condition, what will be the design capacity with respect to the traffic volume. Okay, so each and every stretch of the road should have a traffic road inventory. Then traffic studies. So these traffic studies include traffic volume studies along with composition. Composition is nothing but what are the different types of vehicles that are moving in a particular road stretch. Okay. So then origin and destination studies. So what is the origin point of the maximum traffic and where they are reaching to. So that is what is the origin and destination studies. So for this, we can conduct a survey among the road users. Then we have speed, travel time and delay studies. So what are the normal velocity or average velocity of moving vehicles? And then what is the travel time or time of travel taking from reaching from point A to point B or from source to the destination? And then delay studies. So delay studies can also be taken through surveys, like asking the commuters how much it is getting delayed every day. So like that, we can have an inventory related to speed, travel time, and delay studies. So then accident studies. So because you know, a lot of accidents have been happening in urban locality. Okay. So there are signboards installed in where there are more, chances of accidents. Okay. That is called as accident prone locations. Okay. So that studies has to be taken care. In case, to be frank, so around 12 years back, we had conducted accident study analysis for Tumkur city. So it requires in-depth understanding about how the accidents are happening, what are the reasons behind that, what kind of vehicles are meeting the accidents, like two-wheeler to two-wheeler or two-wheeler to auto rickshaws or auto rickshaws to light motor vehicles or light motor vehicles to heavy motor vehicles. So like that. And considering past 15 years of data, so we should have a thorough accident study analysis of a particular road stretch or in an area. So it will give more information about understanding or finding the solutions for effective traffic management. So then signals and parking locations. So where are the signals, whether it is required or not, what is the time duration of those signals, whether they are functioning properly or not, and then where are the parking locations, are they in the proper zones or points where it will not lead to any traffic congestion. So combining all these factors, whatever I have mentioned, so if we club all together, then we can reach to an effective traffic management. So here I have tried to present some of the photographs related to these causes for traffic congestion. So here you can see there is a construction activity going on, a metro rail construction. So in which you can see beside of that construction activity, there are a lot of traffic congestion and accidents leading to traffic congestion. Then poor infrastructure. Here you can see how many potholes, big potholes are also there, which are leading to traffic congestion. So not only that, so in rainy seasons, commuters will not be able to know what is the depth or dimension of these potholes, and they fall down and get injured very badly. So these are the things which causes traffic congestion. And then another important factor in our Indian context is discipline. There is no lane discipline. So everybody will be, excuse me, can I have a sip of water? Sorry. So I'll just stop video so that it will be having a better connectivity. Yeah, so I was talking about this poor discipline, that is not maintaining proper lanes, two-wheelers or cars or buses. So everybody will start moving in an episode random manner, and it will cause, especially in junctions. So commuters will be coming from either side of the junctions and leading to lot of traffic jams. Then, excuse me. Then coming to this advanced technology for better traffic management. So here I have mentioned some of the technologies, that is global positioning system, cameras, that is artificial intelligence cameras, radar technology, and LIDAR, that is laser based technology for traffic management. So here I have also mentioned strength and weakness of each and every technology. Like if you consider global positioning system, it can track movements of vehicles. and it can also report traffic jams. Okay, so but the weakness of this particular technology is that it cannot take care of or take account of pedestrians or motorcyclists. Okay, so GPS can be installed in any of the, either we can have a GPS in our hand, or a motorcyclist can keep a handy GPS system in his pocket or in his vehicle. So we will not be able to identify what kind of vehicle it is. Okay, so that is a disadvantage of global positioning system. So next, coming to this artificial intelligence cameras, so it can record color images. Okay, so and then it will be easy for us to recognize what kind of vehicle it is, and based on the recognition we can have a classification of vehicles, whether two-wheelers are more, or light motor vehicles are more, or heavy motor vehicles are more, or public transportation system is more. But coming to the weakness or disadvantage of having camera is that it cannot capture or record the video during bad weather conditions or bad light conditions or in darkness. And at the same time, it will not be able to provide 3D information of the vehicles. Okay, so it can, we can have a 2D information, but it will not be able to provide 3D information. Next, coming to this radar technology. So we can have a speed monitoring information, or at what velocity the vehicles are moving. So that data we can get, and at the same time, this technology will be very helpful in traffic surveillance. Okay. So when it comes to the disadvantage, then we will not be able to classify vehicles because the resolution, the what we call it as the spatial resolution of this radar technology is very, very low. So because of that reason, we will not be able to classify vehicles. And the next technology is LiDAR, which is a laser-based technology. So this provides a lot of advantages or strengths, like provide 3D information, easy to distinguish different road users, collect data in difficult weather and lighting conditions, then record speed to analyze traffic flow or the cause of traffic jams, maps of traffic prediction, and suggest alternate routes. So one of the most advantageous system or technology to manage traffic better. So the disadvantage of this is it cannot detect color. Okay, so these are the advanced technologies that we can adopt in for better traffic management. So some of the commonly used technology is global positioning system. Okay, so nowadays we can have a GPS system, that is handheld GPS system, even for 7,000, 8,000 rupees, and many higher end cars are having global positioning system installed in it. And even school buses are also using this global positioning system, for safety purpose. Whereas if you take LiDAR and radar, in India, we are not having that much of usage of these two technologies. Cameras we see in every junction or in every signal, the cameras are being installed, so which will be operated by the traffic police department to track the traffic rules break. Okay. So as I mentioned, so advanced or higher end cars are having a GPS system installed in it. Then cameras, you can see here in these images where the cameras are installed to a pole on the at the junctions. And then here 3D radar technology, which is installed in an express highway of at New Delhi. And then here you can see LiDAR system is installed in a vehicle at the top, which will be able to conduct the survey of highway. Then coming to this spatial technology. So when I talk about spatial technology, it is a geospatial technology which includes different category of technology, that is remote sensing technology, GIS technology, GPS technology, and other technologies. Other technologies includes like using artificial intelligence, otherwise conducting manual surveys or having a terrestrial photographs. So to have the information related to traffic and road inventory. Okay. So let us look into one by one. So when it comes to remote sensing, so remote sensing is nothing but it is getting an information about an object or phenomena without coming in physical contact with that particular object or phenomena. So this is a very useful technique whenever there is a difficult situation that is going to the field exactly and getting the information. Okay. So in that case, remote sensing provides more efficient or effective tools to get the information about what is the process or phenomena happening, whether it is a biophysical phenomena or chemical phenomena or anything it could be. Okay. So when it comes to remote sensing, we have two types of remote sensing. One is active remote sensing and another one is passive remote sensing. Okay. So one of the best example for active remote sensing is that, say when we have DSLR camera in our hand, if you switch on the flashlight, then that will be an active sensor. So which means that it will emit its own, radiation or energy or light, and again it will collect back the reflected energy. Okay, so the instrument itself will be the source of energy for active remote sensing system, whereas when you come to passive remote sensing system, sun will be the source of energy. So if you take the same example again, DSLR, when you switch off camera and when you capture a scenery, okay, so there we are using the light source, sunlight source, natural light as a source of energy. Okay, so here in this particular image, I have considered passive remote sensing system where the sunlight is a source for getting the information. So when the sunlight hits the target or any earth surface feature, that will be having a reflectance. So the satellites or sensors, so that are there, will record the reflected energy. Okay, so this energy in physics we call it as electromagnetic radiation. Okay, so the source of the energy will be sun, and the reflected energy from the earth surface features or targets will be recorded by the sensors. So these signals will be later converted as images. So as I said, electromagnetic spectrum or electromagnetic radiation. So here you can see gamma rays, X-rays, ultraviolet rays, visible light, near infrared, thermal infrared, microwave, and radio wave regions. So when we move from left to right, where at the left side, the frequency or energy of the waves will be high. And when you move to the right side, then wavelength will be high and frequency will be very low. So from gamma rays, X-rays, and up to ultraviolet rays, we have a lot of applications in the medical engineering field or medical sciences. But when it comes to visible light, we have three types of remote sensing. That is the optical remote sensing, which will utilizes this visible band or visible region or optics. And then we have thermal infrared region, where we will be able to record the emitted energy. Like for example, if you take heat emitted during a forest fire, okay, so that is based on the phenomenon of heat. Okay, so we can capture images using thermal infrared band or near infrared band. And then microwave. Okay, so microwave will be having a longer wavelength compared to visible or optical region and thermal infrared region. So the advantage of this microwave remote sensing is that it can penetrate through thick clouds, and it can even capture images during bad weather conditions and even during the night time. So these are the two limitations when it comes to optical remote sensing and thermal infrared remote sensing. However, this bands or energy in the optical band and thermal infrared band will not be able to penetrate through thick clouds because its wavelength is less compared to microwave region. So here I am presenting the different stages in remote sensing. So the first stage is the source of energy. So as I mentioned, if we consider the passive remote sensing, then sun will be the source of energy. The electromagnetic radiation that is coming from the sun will hit the different features that are present on the surface of the earth. Okay, so when I talk about different features of the earth, you can see here there may be forest, that is trees, water bodies, grasslands, bare soil, paved area or paved roads, and then concrete buildings, or it is in general, we can call it as built up area. So these different types of earth surface features will interact in a different way for against this electromagnetic radiation. Okay, so there are a lot of process involved when it comes to the interaction of electromagnetic radiation with earth surface features and as well as in the atmosphere. So here, when the radiation is coming out of the sun, it hits the clouds. So where in which two phenomena happens, that is, one is absorption and another one is scattering. So we have different types of scattering mechanisms that I'll not be going in detail. So what I'd like to tell you is that the brief process in the remote sensing. Okay, so some of the earth surface features will reflect more energy. Some of the earth surface feature will absorb more energy, or a water body. Okay, so it can transmit more energy through it. So whatever the reflected energy from this earth surface features can be recorded by sensors, which are attached to different types of platforms. Okay, so platform is a one which carries the sensor. So basically we have three types of platforms. One is ground-based platforms, then airborne platform, then space-borne platform. Okay, so ground-based platform is nothing but, so it will be very close. The sensor elevation of the sensor will be very close to the surface of the earth. So it may be fixed or fitted to a watchtower, or a sensor can be attached to a vehicle. Okay, so the distance from the earth surface feature or earth surface will be very, very less. So when it comes to airborne, we can use aircrafts or the recent technology that we are having, drone technology. Okay, so this comes under airborne platform. Then when it comes to spaceborne platform, we will be utilizing satellites. Okay, so which are having a higher altitude from the surface of the earth. So whatever it is, once the data is captured by these sensors, it will be retrieved through the system and it will be converted into data, either in the form of a tables or in the form of an images. Okay, so then analysis will be carried out, and then interpretation will be carried out, and then the results of this analysis will be presented in the form of maps or images or data sets or anything it could be. Okay, so this is all about the stages in remote sensing. So as I mentioned, so we will be having different earth surface features which are in general called as targets. Okay, so here you can see sun is the source of energy. So when the electromagnetic energy hits the target, and then depending upon the type of the earth surface feature, there will be a reflectance value. So we call that as albedo. So each earth surface feature will be having different albedos. Okay, so based on the characteristics of the target, it will reflect some amount of energy, and the reflected energy will be collected or recorded by the sensor. Okay, so when it comes to remote sensing, so we should understand the spectral signatures. Okay, spectral signature curves of different earth surface features. So in the top left image, if you see, there are three features. One is dry bed soil, vegetation, that is green healthy vegetation, clear water. Okay, so if you see this graph, on the x-axis we have wavelength, okay, energy in terms of wavelength, and on the y-axis we have reflectance in terms of percentage. So if you see here, the water is having very less reflectance, so which means that major portion of the energy that is radiating from the sun and hitting the water body, either it will be absorbed or transmitted through the water. So that is why the reflectance will be very, very less. Again, it depends on the quality or the presence of impurities in the water body. Okay, so and then chemicals, impurities, sediments. Okay, so particles and then turbulence, everything matters when it comes to reflectance characteristics, but the trend remains the same. So the reflectance of this water body will be in the wavelength region of 0.4 to 0.8 only. Then when it comes to the vegetation, so here you can see 0.4 to 0.8 is a optical region, that is visible band of the electromagnetic spectrum. So then after there is an IR band. So in the IR band, healthy vegetation will have a more reflectance, up to 50% reflectance, depending upon the concentration of the chlorophyll present in it. Okay, so again, up to the wavelength of 1.4, probably up to microwave region, it will be having a higher level of reflectance. So then after, the reflectance of this vegetation will drastically reduce and it goes on. Okay, so when it comes to dry bare soil, so you can see that the reflectance starts at 18% itself. Okay, so again, it depends upon what is the characteristics of the soil, whether what type of soil it is, whether it is a clay or laterite or sand particles or seashore sand, something like that. Okay, and again, the presence of organic impurities. Okay, organic impurities present in the soil will also affect on the reflectance, or presence of moisture will also influence on reflectance characteristics of uh, dry bare soil. Okay, so when it comes to this second image, here you can see pine woods, grasslands, red sand pit, silty water. Okay, so if you see this vegetation, the trend, okay, trend of this curve of the vegetation will remain the same. That means the maximum reflectance will be there in the infrared region, that is immediately after the visible band. Okay, so and then when it comes to the third image, here I have presented different reflectance curves or spectral signature for different features such as grass, concrete, sandy loam soil, shingles, fallow land, asphalt, artificial turf, clear water. Okay, so here also you can see for grass, after visible band or optical band of the electromagnetic spectrum, the reflectance is maximum. So when we are understanding a particular feature, we need to have this spectral signature information. So using this spectral signature information, we can identify different types of features, whether it is a concrete or an asphalt or anything it could be. So when we are extracting road information or road networks, so we can use the image captured in a green band. Okay, so that will give more information, or depending upon the tone, that is the road network or road surface will look more brighter. Okay, so it will be easy for us to identify the road network and we can extract the road networks. So another important topic or points that one has to know about when it comes to remote sensing system is resolution. Okay, so when it comes to the sensor system, we have four types of resolution. One is spatial resolution, second one is spectral resolution, temporal resolution, and radiometric resolution. Spatial resolution is nothing but what is a area or ground area covered by each pixel in the image. So that is called as spatial resolution. More the number of pixels in an image, higher will be the spatial resolution. Now, lesser the number of pixels in an image, lesser will be the spatial resolution. So then spectral resolution is nothing but the ability of the sensor to bifurcate a particular band into number of bands. That is called as spectral resolution. Then temporal resolution is nothing but the revisit time of any particular sensor to capture the image at a same location. It could be 1 week or 1 day or 17 days or 28 days or once in a month, like that. So lesser is the time duration, higher will be the temporal resolution of a particular sensor. Then radiometric resolution is nothing but it is the sensitivity of the sensor to the magnitude of the received electromagnetic energy. So depending upon the project that we are going to take up, so we need to have a particular type of resolution. So here I am presenting a pictorial representation of remote sensing platforms of satellites. So we have a spaceborne platform, then aerial platform, and then ground-based platform like unarmored vehicles like drone. Okay. So then next important spatial technology is geographic information system, or it is also called as geographic information science. So which deals with the spatial information. Okay, not only the spatial information, we will be having non-spatial data integrated with the spatial data also. Okay, so here we will be using a computer system which are having, softwares like GIS softwares, and then hardware components and so on. So when it comes to the functionality of this GIS, so GIS can acquire the data or capture the data and store it. That is called as data collection function. And then we can have a data storage, database management system, query the data, analyze the data. That is the second functionality of the GIS. And the third functionality is the output production in terms of or in the form of images, maps, or data tables. So here you can see we can use GPS, handheld GPS to acquire the data, and through a data transfer cable we can export the data collected to a computer, and we can import that data to any GIS software. So we can get the data that is captured by the satellite sensor. We can create 3D maps, or we can analyze the images. So here we have data storing, processing, and analysis. We can conduct different types of analysis. Lot of analysis tools are also available in GIS softwares. Then we can produce the output in the form of statistical reports, maps, images, data tables, and so on. So when it comes to the GIS, so these are the different components, okay, in detail of components of GIS. So we will be having a satellites as source of data. It will be having a software. Then we will be having multiple data. We can carry out analysis. We can produce maps, or we can have apps. So that will be working based on web GIS servers. Okay. So we can directly transfer our data to servers where other people can access this data, and we have a lot of career opportunities in remote sensing and GIS, that is spatial technology. So when it comes to the data, we will be having spatial data, attribute data, data layers, layer types, that is raster data layer, and then vector data layer. Spatial data means it will be having location information of any feature of interest. Then attribute data is nothing but it is the information about the spatial data. Then data layer is nothing but merging the spatial data as well as non-spatial data, that is attribute data together. It is called as a data layer. Then topology gives indication of how different features are interrelated. Okay, so that is called as topology. So here we can have data from different sources such as analog maps, aerial photographs, then satellite images and reports. Okay, so these are the different types of sources of data to work with GIS. So when we have real world, so we can extract different types of data, that is called as thematic layers. Okay, so if I want to have the data pertaining to only road network, then I can extract from the satellite images. If I want to have information about only urban settlements or building settlements, then I can get only that information, that is called as another theme layer. Then we can have another theme layer which will be having only vegetation related information. So when you club these kinds of different data, then that will be the real world. Or when you integrate different types of thematic layers, then that will become the real world, or it will represent the real world scenario. So then global positioning system. So global positioning system is used to find the or to track the location of any either stationary or moving object. Either it could be vehicle, or you may be holding a GPS system in your hand and moving across. Okay. So this GPS device will have a communication with GPS satellites, and then you will get the location information. So this will be used specifically for navigation purpose. Okay, so which is highly accurate compared to conventional surveying methods. So let us discuss briefly about working of GPS. Okay, so here we have three segments, that is space segment, control segment, and user segment. So space segment is nothing but the number of GPS satellites that are encircling or revolving around the Earth. So we have 29 satellites which are revolving at every 12 hours duration at an altitude of 12,000 miles. Okay, so control segment is nothing but the data transfer happens from this control segment, which is having monitoring stations with atomic clocks attached to this control segments. That is called as master control stations. We have 5 monitoring stations across the globe. And then the third segment is user segment. That is GPS receiver. So the user community who will be having GPS receiver with him or her. Okay, so which will be having or getting the signals, okay, from the satellites or space segment. So here the brief pictorial representation of working of GPS. So here you can see the space segment is there, then user segment is there, and then ground station is also there. So here you can see the constellation of GPS satellites. So for the GPS to work, so work is nothing but getting the better accurate location information. The GPS receiver should be connected at least to 4 satellites. Okay, so why we require 4 satellites? One is for latitude, longitude, and then altitude. So what is the purpose of 4th satellite? It is required for time computation. Okay, so time is also another dimension. So with respect to time, so you may be moving if it is a dynamic condition. So in that case, with respect to time, how your location is being tracked. Okay, so that is why we need at least 4 satellites to get the location information. So more number of satellites in connection with the GPS receiver means you will get higher accurate information about the location. So next, the more advanced or recent technology is drones. Okay, so we have different types of drones that are designed for different applications. Okay, so here you can see a camera mount is there at the base of the drone, and there we can replace the camera as per our needs. Okay, so it will be having a remote device wherein which that is called as ground control station. Using this ground control station, you can monitor the movement of this drone. So next, coming to the applications of this spatial technology for better traffic management. So we can have this highway maintenance information management system to have a better traffic management. So here I have presented a flow chart, so which includes the different components for highway maintenance and management. And in order to maintain the quality, so we can have the information related to pavements, subgrade conditions, then bridge, tunnel, and culvert conditions, then traffic facility conditions, and so on. So more the data you have, better will be the management system. Then another important application is traffic events management. Okay, so here I have presented the framework of the approach. So here you can see data acquisition is the first step, then information analysis and relevant data, and then we have creation of dictionaries or and equivalents, and then it goes on. Okay, so this is a framework for having a traffic congestion analysis. Okay, so based on WebGIS and data mining of traffic events. So here you can see traffic conditions and event. So this is one of the case study. So from where I have taken the information. So here you can see number of occurrences of events. So when you convert this kind of data into a map, you will get a information in the form of a map like this. So here you can see the color variations, blue to red. Okay, so red indicates higher number of events, that is traffic conditions or worsened traffic condition, and blue color indicates better traffic condition. So like this we can have a traffic congestion analysis. So based on the events, data collected pertaining to the traffic conditions. Then one of the another major application of the GS or geospatial technology is accident zonation. Okay, so here you can see this is an example of locating accident prone areas all around the schools. Okay, so wherein which students will be or kids will be more exposed to the accidents. Okay, so like this we can create accident zonation maps. Then this is another example of Thiruvananthapuram city. So wherein which the study includes mapping of or clustering of road accidents. Okay, so like this, once we have the data of for a longer time duration along with location, how the accident happened, what is the reason behind that, what are the types of vehicles involved in accidents, so we can create maps like this. So this is also another example of accident and traffic analysis of Coimbatore district. So here you can see, the red light, red color, then orange, green. So red indicates the most probable, zones of accidents. Okay. So and then orange indicates the moderate level of accidents, and green indicates, safer zones. Okay. Then here we can also have a mapping, so which indicates different types of a road network. Okay, either it may be corridor or highways or express highways or interior roads and so on. And then in our day-to-day life we are using this Google Maps for better route planning to go from starting point to the destination point. So we can also change or find alternate routes. So you can skip toll gates if you want, or if you want to miss traffic congested area. So in that case also we can provide information. So the Google map will provide us the proper alternative route to pass through. Then here one more application, so that is related to the landslide hazard. So here you can see this black line shows the road network, and this is a hilly region probably or mountainous region. So if there is a landslide happens, what will be the portion of the road that will be in risk, okay, because of this landslide, or the infrastructure of this road network can get damaged. Okay, so like this, for different types of natural hazards we can have a maps based on predictions. Then this is another application of route optimization. So one of the example is, like for example, sustainable waste management. So you can have a road network map, and then you can have a location of bins in a particular locality. Okay, so if you have this data along with the time of travel, if there are any signals, that is called as impedances, or cost of traveling, cost involved in traveling. So you can all you can use all the data in the GIS system to have a route optimization task. So here you can see we have two service map for first vehicle and second vehicle. Okay, so it will show us the shortest path to reach from the starting point to the ending point. And the other one is that time value. That means if time is a constraint, so what will be the shortest path, or path that I can take to reach within the time? So these kind of analysis can also be done in GIS softwares. So here also there is another example of shortest distance path, shortest travel time path, and then actual path. Okay, so we can find out alternate routes to commute from starting point to the destination point. So this is another advanced application that is most probably there in foreign countries. So we have vehicle detection using drones. Okay, so in left side image you can see that vehicles that are moving along the road are being tracked or identified. Okay, so in the right side image you can see a lot of vehicles that are in the parking area. Okay, so like this we can have number of vehicles that are either transiting or in the parking area. So then this is another application of this spatial technology, where in which we can have a camera attached to a vehicle, which will be able to take the pictures of road conditions. So there may be a crack, or it may be a construction joint, or it may be potholes, presence of potholes, alligator track, or there may be deterioration of this zebra lines or crossing lines or paints. So this kind of things can also be monitored time to time in a lesser time for better traffic management. So we have machine learning algorithms and deep learning algorithms that can be implemented on the images that we have captured or procured. Okay, so those algorithms will be able to identify these kind of features, which will give more information. Then this is another application of alternate route alignments. So here you can see the alternate routes have been identified by using different methods, that is rank exponent, ratio estimation, rank reciprocal, rank sum up.
Santosh, 1 minute. Just check whether your slide is moving. It is moving for me. Maybe due to internet problem, it may be that. Because for me, it is moving.
For me also it is moving. I don't know for others.
What about others? Can anyone respond to that? Whether it is
Sir, it is moving. It is
Okay,
moving,
fine.
sir.
Fine. Done. You can proceed.
Yeah. So here it is from one of the case study. So where in which the alternate route alignments have been identified based on these methods, and it has been overlaid on digital elevation model, which is a 3D profile of the Earth surface. Okay. So that is another application. And here in the another picture, we can carry out buffer analysis or proximity analysis. So if say you consider an example of road widening or realignment of the road network. So in that case, we will be interested to know how much of the land or habitants will be coming in that particular width, extra width. So in that case, we can have this buffer analysis. So then another example of this route alignment, that is from Haridwar to Roorkee, Uttarakhand. Okay, so here also some of the methods the authors have used, that is rank exponent, ratio estimation, and so on. So here you can see what will be the total length, what will be the existing road length, and what is the balance road length that has to be extended. Okay, so in each method, the alternate routes are being identified. So another application is to find out the closest facility. Okay, so it may be for business purpose or moving purpose. Okay, so if there is a school, so what will be the different ways the school bus can go along and pick up the students? Okay, so that is one is location and allocation based studies. So another one is efficient routes for vehicles in dynamic traffic speeds. Okay, so depending upon the dynamic condition in the traffic, so what will be the shortest path or efficient routes that the vehicle can take up, so that the cost involved, cost with respect to time, cost with respect to fuel consumption can also be minimized. So another application is environmental related application, that is our ecological risk assessment. Say here in this particular case study, so there is an highway here demarcated in the top image. So if there is an expansion, so what will be the risk to the local environment? That is called as ecological risk level. Okay, so that is being analyzed in this particular study. So here we can see that the risk is being categorized as low risk, moderate risk, and high risk zones. This is related to environmental impact assessment or ecological risk assessment using spatial technology. So this is the last part of my presentation. That is, I'll be concluding with these remarks. So spatial technology provides most efficient and robust tool sets to assess and monitor traffic movements. So, but the cost involved, that is initial cost to procure the data, to procure the, hardware part, software part, and extra, integration tools, it requires high initial investment. So it is not only about having the software or hardware component, it is all about having the data, both with respect to quantity as well as with respect to quality. Okay, so we need huge data set and having a error-free data. So that is very challenging when it comes to spatial technology. So then one of the advantage is that we can have WebGIS servers to transfer the data in real-time condition. Okay. So to collect the data, so which is very much essential for this spatial technology, that is ground-based information, it is very challenging in many of the applications. So in spite of all these applications, the spatial technology for traffic management or in the transportation field has proven very much advantageous. So which will provide us better output in less time, and then a more efficient information or more efficient tool to get lot of information, because this GIS we can conduct lot of queries. Okay, so based on the coding languages or Python, we can conduct the query analysis and get the information that is very much essential to take decisions for better traffic management. So here is a last note from my end. Adding highway lanes to deal with traffic congestion is like loosening your belt to cure obesity. So which means that it is not about expanding the lanes. It will not solve the problem. Okay, it will not solve the problems. Instead of that, we have to have a strategy for better traffic management system. Thank you all.
So very thanks to my dear colleague, Dr. Santosh. Now the session is open for discussions and any queries. I think one question has come in chatbots. Can you read that?
Yes.
Yes.
It is possible to develop a real-time traffic signal timing system using GIS. Is there such a system developed anywhere in India? So in India, I don't think so. I have not come across such kind of application, but in abroad, it may be there, because homogeneous traffic conditions, it is easy to, manage. But in our condition, it is very difficult.
No, okay. If anybody want to unmute, they can unmute and ask. Now another question is use of QGIS. Can you throw some light on that?
Yes. So obviously it is possible, but since QGIS is a freeware, so readily available tools are very, very less. Okay, but if you take commercial softwares like ArcGIS, you have lot of mathematical tools already built in the ArcGIS software. Even if you take Google Earth Engine as a data source, you can do a lot of things in ArcGIS. I'm not saying that QGIS is not possible. Of course, you can use QGIS for getting the information using the data that you have.
Now, another question it has come to us is, can you discuss some softwares which can be used?
So in particular for traffic management, I am not aware of that much, but once you have the data, you can use GIS softwares like UGIS or ArcGIS or IGIS, wherein which they have, tools for spatial analysis tools or network analysis tools to carry out these kind of analysis, and you can get the information.
Another question that asked, one question has come from Prithviraj. Can you read that?
Yeah, what is the research work which can be carried out in future with the GIS and traffic field? So it is actually a very good question. The thing is, so everybody is concentrating on reducing the traffic congestion. So you can try to develop a model incorporating the data, available data, that is realistic data, and prepare a model, or you can even set a signal timings. Okay, so to reduce traffic congestion. So on this line, you can work. Otherwise, you can, nowadays, there are a lot of potholes, right, in the road. So you can work on, having a device which will track these potholes. Okay, so that will be very useful for the government sector to fill up those potholes like that. And even accident study analysis, you can go in depth and analyze the causes for accidents in a particular area or in particular road stretch. So that is also a good topic.
One more question as asked by Rishmi. Can you go through it, please?
As a large amount of data required for deep learning techniques, is there any specification in minimum number of data to be collected? So actually, the more the data you have, more accurate will be your work. So if you have minimum data, so it will be whatever the information that you will get after analysis, it will be totally unrealistic. So try to collect large amount of data for a longer duration. Okay, so larger the data, the output accuracy will be better.
One more question is, now once you want to work in this platform, you need some sources of data. For example, the maps you will get. Whether any maps are freely available?
No, maps are not freely available. So you can use satellite images to, get the road network map, or you can have a digitization. Even algorithms are also available to extract these road networks automatically. If the geographical area is large or your study area is large, it may be difficult or time consuming to digitize that road network and get the information. But you can use such kind of algorithms. Those algorithms will extract the road network automatically. So then after you have to build a attribute data. Okay, so once you have the spatial data, it is a challenging task to build the attribute data. Okay, so this traffic department, like for example, if you're conducting accident study analysis, you go to a local traffic police station where they will be having databases of accidents happened over a period of time. So all the information will be there in that. You make a entry of the data, or if it is available in the form of a soft copy, that is very, very much helpful actually. So you can directly, import that data into the GIS and do the analysis. Building the data, spatial data, attribute data takes a lot of time. It requires a lot of patience. But once you have the sufficient data, so analysis is not a challenging thing.
One more question is asked, what about the accuracy level?
That's what accuracy level depends on the quality and quantity of your data. What are the impedances that you taken care of? Okay, so all those things comes under the accuracy.
I think one more question has come.
How can we select an error-free satellite image? So there are a lot of open data sources available. Like if you take USGS or our Bhuvan, okay, IARS ISRO Bhuvan website. So you can download data of your particular study area. But only thing is that don't take take satellite images captured in monsoon season or winter season, where in which there will be cloud cover. Okay, so there will be more chances of information loss. So try to download the data of a summer period. Okay, so you can have a cloud-free data. Or if there is any error, like for example, Landsat 7. So there are set of where Landsat 7 image is having a missed scan lines. Okay, so in that case, you can use filtering algorithms to get the missed data or to remove those errors. So we have different types of errors in remotely censored satellite images. So and filtering algorithms are also available to rectify those errors. So my suggestion is use the images, satellite images acquired during summer periods.
One more question has come.
Can we identify potholes from satellite imagery itself? No, that is not possible. But if it is a larger potholes, then it may be possible, but provided you need to have a higher spatial resolution data. So the spatial resolution of the data, it should be in the order of 0.5 centimeter. Okay. So or 60 centimeter like that. So in that case, it may be possible to just to view the potholes, but if small potholes are present, it is not possible. Okay, so if you take quick bird data, so the spatial resolution of that image is 60 centimeter. So if a pothole is bigger than that size, so it may be possible to see in Google Earth image. Okay, so if a pothole is of having very less dimension, it is not possible.
One more question has come.
In Kerala, most roads are covered with the trees. Is it possible to analyze with this? It depends on how much is the coverage. Okay, along the entire length of the road stretch, it is there. Then it may not be possible. But here and there, if there is a tree, tree cover zones, then it is possible.
One more question has come.
Can we
Vinod
use?
J.
Yeah. Can we use list to identify potholes and integrate that data to GIS for further analysis? Yes, you can do that. You can integrate potholes information to the GIS environment, and then you can carry out the analysis. But instead of that, better to go for, you can even have a, density of potholes and dimensions. So that data can be incorporated in GIS software, and you can do that. So that is all related to, see, for example, if there are a lot number of potholes, then time of travel will be more, right? So you can incorporate this pothole information indirectly in terms of time of travel. Okay, so you can have some multiplication factor or weightage. So that will represent indirectly this presence of potholes. So like that you can do.
I think now no more questions are there. But what I feel is your presentation was very effective because a lot of questions has come from the audience. So with this, what I feel is we will end this session.
Yes.
So if you have any other queries, you can mail to us.
Yeah.
So we will forward to sir and he will reply you to all.
Yeah.
Now,
I would like to, excuse me. Yeah, I would like to thank Tata Smart Solutions for providing this opportunity to present a technical talk on spatial technology for better traffic management. My special thanks to Dr. Vivek Das sir, so for organizing everything. And more than that, I'm very fortunate to have a first lecture of this technical series. Thank you very much.
And now over to the conference team. So you can end the session. So you can tell the end note.
That is a wonderful presentation from Dr. Santosh, and thank you for clearing our doubts. Now, I am to invite Engineer Deepthi, the Honorable District Secretary, AOEK, to deliver the vote of thanks.
Hello.
We can hear you, madam.
Hello.
Hello, we can hear you.
Okay, thank you. Good evening, everyone. I'm Deepthi, District Secretary to Thiruvananthapuram from Kerala State. So it has been an honor to me to be the part of this technical session. As public servants, one of our major problem that we face in our job is especially related to roads. It is traffic management. Maybe mainly due to the increase in number of vehicles and lack of enough
please, your
space.
video is on.
Sir, hello.
Hello, yes, madam. Tell me.
Okay. So it is the major problem that we are facing in our job, especially related to roads, is traffic management. Maybe because of the increase in number of vehicles, and we don't have enough space. That is maybe due to the lack of enough space for road development. And sir has explained much about the effective traffic management using spatial technology. As said by him, the spatial technology is a very effective method with a faster output for better traffic management. So we had a detailed and updated session about the technology. So on behalf of our organization, Association of Engineers Kerala, I would like to extend my gratitude to Dr. Santosh LG, the speaker of the session, who rendered such an updated and detailed session about the spatial technology for technical management. And also, I would like to thank Turtle Smart Talk series to give an opportunity for us to be a part of this session. And Dr. Vivek Adas, Associate Professor, Ramaya Institute of Technology, Bangalore, for his formal introduction.
Excuse me,
Yes.
ma'am. There is a video. I just forgot to play it. So even now the participants are there. Can I play that video?
Yes.
Yeah, just give me a minute. So it is just a 3 minutes video. It will give more information for the participants.
Okay.
Can you see this video?
Yes, sir.
This is a video captured by using drone technology, okay? Yeah, thank you for watching. This is
Thank you.
what we can do with drone technology. Thank you, sir.
Thank you. Madam, you can continue.
Okay. Okay, sir. So I'm continuing that. Last but not the least, I would extend my humble gratitude towards all the fellow engineers who participated in the session, especially our General Secretary, Sri Vinod, and our District Secretary, District President, Srimati Ganga, and our technical committee. So on behalf of our organization, I am once again thanking Sri Dr. Santosh LG for such a nice session. Thank you.
Thank you.
Thank you. Thank you. Thank you. Have a nice day. Thank you. Good night.